you so much for coming in today. My name is Ez, and today I'm going to talk to you a little about our new innovations at Sapienta, and we'll detail some of the new findings that we found regarding some of the detection models that we worked on. Detection models is probably not the best word here. It's more of a correlation model. However, it allows you to detect attack flows and detect coordinated attacks instead of wasting all of your time on false positives, wasting all of your time on isolated attacks, and so on and so forth. Let's start with a story. You are working in an organization, OT, IT, whatever, and you have a breach. And this breach is causing you to think, like, how did this happen? We had enough budget to buy all of the detection tools, the prevention tools, and I had a SIM, or I had a log aggregation. So I had access to all of these events, logs, and alerts. How did I not stop the breach? It's not because of a 0 day. The breach just happened and left a lot of traces on my SIM, or on my logs, or on my events or alerts. So I have the data to trace back essentially what happened. But why did I not? As you reflect more, you're thinking, I should have probably investigated better. At the end of the day, I am the investigator. I have a colleague that is my triager, like they're triaging stuff and they're sending me stuff that I should be looking at. I should have investigated better. Maybe they made a mistake on triaging. Maybe they thought something is not important, but it was actually part of an attack story. But still, I should have been able to investigate better. But how do we investigate? Do I just sit there, look at an alert in my SIM, and I think, what should I search to find relevant alerts? What should I search to find relevant logs and events? Is that how I should do it? Is that how I should investigate? And if so, how could I possibly search all of these alerts that I'm getting every day? Even a lot more in terms of telemetry, in terms of events, in terms of logs. How could I possibly search all of these to effectively find related and relevant data points to an alert or to an attack that I'm investigating? I mean, at the end of the day, attacks are so stealthy, they end up hiding in the noise. They are so happy with the noise that we're all very familiar with that they are known to create more of these noises, right? So you would have an attacker create a lot of decoy attacks and essentially generate a lot of traces at your system so that when they actually launch their actual attack, you are kind of drained out already. And that's why, on average, we are looking at ridiculous timelines when it comes to containing breaches. It's so ridiculous that we cannot understand why do we have so many innovations and so many tools and so many AI companies and so many consultants and so many products, and yet we still seem to be ineffective at stopping breaches. Breaches are a common thing. I know if I do a show of hands here who worked through a breach, I probably would not get a lot because people are usually ashamed and they don't want to say that they went through a breach. But we know as security professionals, it's not about if, it's about when. You definitely went through a breach. And that's why we have come to a consensus that, you know what, maybe the industry and the tooling is a little bloated. Maybe we don't have a way to effectively use these toolings. And we've heard a lot of leaders talk about, people, process come before technology. So maybe it's not about the technology, maybe it's about the people and process. I don't know. But whatever it is, it's have bigger and better budgets, and we have worse and worse breaches. So is it about catching up with the attackers? Is it about using the right techniques? We will investigate that. But before we go into that investigation, let's focus on SOC surveys that come from people that work in the SOC every day. And these seem to always highlight the idea of correlation. Correlation is a terrible word because you've seen it every day in every product as a correlation rule, correlation whatever. Marketing has washed down that term. I prefer a term of contextualization, or essentially finding relevant data points. If I get an alert, how do I find relevant data points? Do I find relevant data points by searching for a common characteristic in that alert? So I get an alert from Ez that Ez is trying to log in at 1 a.m. for some reason. Do I just search for Ez? Is that the only thing? Do I look for what he was trying to log into? Do I also search for that? When I do these searches, am I looking in the last 5 minutes, in the last 10 minutes, in the last 10 years? It's a search, right? So this idea of finding relevant data points, today, it seems like we don't have the right tooling for it, but let's investigate this a little further. What tooling would help me with all of that cyber noise? Every single asset today in your organization has a lot of telemetry, a lot of logs, a lot of events, and ideally you're putting some sort of alerting on it, so you get a lot of alerts. Very few of these traces that you're generating, and you're probably generating terabytes and terabytes of data on daily basis. You might not ingest all of that into a log management solution, but you are generating them. Some of these traces, like less than a handful of these traces, are actually part of a coordinated attack on your worst days. So hopefully today, none of these traces mean a coordinated attack, but maybe sometime in the future, because again, it's a matter of when, some of these traces will literally be an attack. They are a coordinated and targeted attack from a cyber militia group, from a cyber criminal organization, from a cyber war department, whatever it is, right? But at the end of the day, how do I find these little red dots flying around that are coordinated? The only way to find them is to find relations between them and figure that they're part of something bigger. They're not isolated, they're not siloed, although the generation of these alerts and the generation of that telemetry and the generation of that logging mechanism is completely based on isolated and siloed ideas. Like they're completely disparate. If you look at the Suricata rule, I know Reed from Dragos was talking here yesterday, great presentation about Suricata rules. And people spend their time on detecting stuff, right? Now that we have all of these detections, what do we do with it? Noise. We don't look at it. We look at some of it. We filter on it. We filter on less than a kilobyte, half a kilobyte of what we get in a day, and we get terabytes and terabytes. So why are we generating them, you might ask? Because we hope that our technologies would allow us to catch up. If you remember, in the beginning of this story, you were asking yourself, why did I not catch that attack story? What's wrong with my tools? I have the best tools out there. I have playbooks, I have rules, I have anomaly detection, I have everything. I have an incredible budget, I have a lot of people, I have an actual fully staffed SOC for OT. Yet I still have a breach. And that is not a hypothetical story. I don't want to call anybody out, but there was Colonial Pipeline, there was a bunch of others. So when you have all of these tools, and you know your traces are right there in a management system, why are the tools today not catching up? You might think to yourself, you know what? Maybe it's not a playbook, because a playbook is essentially just a sequence of enrichment. Like when you see this alert and you have access to this API, maybe pull this username and look through this API, enrich as with who does he report to, who does he work for, what do we know about him, what's his risk score, what is his workstation's risk score, what's his compliance on his work phone, and so on and so forth, right? So I can enrich some stuff in a playbook, but is that really what I need? Probably not, because when you look at these attacks and attack stories, they look something like this. As you can see, all the way from the left to the right, and this is the Mitre attack framework. So columns, Mitre attack, are months. So essentially, vertically, you're going through the timeline. Horizontally, you're going through sequentiality. The color coding here is based on machines. So this color is for a machine. Let's call it machine 0. This other color is for a completely other machine. Let's call it machine A. And this other color is for a server of such. And you can see here in the first month, around August 2017, there was an entire full attack story on one machine that ended up going nowhere, and then they launched during that same month an attack on another machine. And that's only what I know from my SIM. So if I don't have observability, I don't know, right? So this is only what I observed. There must be a bunch of 0 days, there must be a bunch of stuff that I couldn't observe, such as stuff on the identities. Maybe someone hacked an account. Do you see here any accounts? No. Because in this attack, I didn't have any observability on identities. Okay, but let's talk about endpoint and network. So in this attack, I had endpoint and network observability. You can see how, not really sophisticated, but you can see how perseverant this attack is. It's almost like a script kiddie was learning. They went through a machine. They were like, oh, that was not a good machine. I didn't target it very well. Let me go through another machine. oh, that second machine might be useful. You know what? That second machine had a credential. Maybe let me use it for a server. And they use a server. And then they go through the server, and they're like, huh, maybe that server was not very useful. And they take a month or two of a break, and then they come back. They're perseverant. They're probably script kiddies. They're probably in school during that time, so they come back during Christmas, and they launch another attack on some of the machines that they retained access to. In this case, it was machine A, the red one. And so on and so forth. And you might think this ends, but no. If you fast forward 6 months into this attack, and this is a real attack, by the way, this is Singapore Health, you fast forward 6 months, you see there's still more activity, still more machines, still more lateral movement, still more activity and perseverance and persistence, until you finally get a jackpot with this incredible brute force of an attack. So the attack here was not stealthy. The attack here was generating a lot of traces. It could be because they wanted to generate a lot of traces and waste your time, or it could be because they're simply human. They don't know what they're talking about. It's a black box test. And a bunch of you might be pen testers that did black box tests before. You know how it goes. You got to try everything out. It's almost like a brute force. You might be sneaky because you're an elite pen tester, but most script kiddies are not. They're essentially just, making a few calls to ChatGPT. What should I do here? What should I do there? And they're trying it out as they go. In essence, how can you possibly piece this together? How could you possibly piece this entire attack story together that, in this case, went over a year? A year of traces on over a dozen of machines. Do you have the capacity to put all of that together? Probably not. Why? Why do we only do this retrospectively? And actually, this was done retrospectively without any forensic teams. So no one dug into essentially these machines to get more data for this chart. This chart is completely based on the data that was already available for the SOC. Of course, this chart has another copy of it with a lot more information that was gotten from the machines and from the forensic teams. But without the forensic at all, you still had all of these logs. So how can you possibly put them together? Well, you can scratch your head. You can think, you know what? Well, I can probably figure out what can I possibly do. What vectors were used? And I see that the vectors were plenty. These attackers, in this case, used multiple rats, used multiple malware, used multiple frameworks. Again, almost as a script kiddie, or almost as someone trying to throw you off your game with a lot of noise. So when you think about this, how could I possibly put all of this together and deal with it as a coordinated attack instead of deal with it as an isolated attack every single time? Because if you see here, every little box, and I can go back a little for some of these boxes are not really worth a lot. Like the first one is initial access on machine A or machine 0. Initial access on machine 0, that means like a drive-by. Sure, you got an alert that someone downloaded something. Big deal. You know what, let me send them a Microsoft Teams message. Please do not download stuff. Come on, this is out of policy. You know you should download stuff, whatever, and that's it. End of game, might be handled by a playbook. I never even hear of it. And so on and so forth. I might not even deal with any of these as if it's a coordinated attack. I might not take any of them seriously. Even at the end of my attack, I'm not taking any of these seriously, because at the end of the attack, there was a database call to the critical database. And if I use that in isolation, I know, you know what, it's just a call to a critical database from a machine that is authorized. So what? It might be an anomalous download for exfiltration. Let me message the person that owns this service machine or service account. Why are you downloading that much? It's kind of weird. But it might make sense because we take backups every 6 months, so maybe not too bad, you know? And again, if I deal with it in isolation, I'm completely blind until the Prime Minister's data is public on the internet. And then my boss tells me, you know what, let's do all hands tomorrow. We have a big deal. And at that point, I go into the all hands. I'm not surprised. Every little thing I dealt with is on there. We triaged it, we investigated it, quote, quote, investigated it, but we never investigated at this depth, which is the depth required to actually see these attacks. So how can I possibly see the full attack in real time? How can I possibly stitch these siloed alerts into what we call causal kill chains? Because if you remember, horizontally, it was sequentiality and causality. There was causality as you went left to right. How can I possibly know what is the stage of the attack plan in this specific incident? Like some of these incidents could be isolated, some of these incidents could actually be part of an attack plan, and this is a stage. So it's almost as if, ideally, I want to pull all of my signals, all of my logs, events, alerts, and I want to put them through this quote-unquote contextualization thing that would show me coordinated attacks and would show me clusters of false positives. And if you notice, I use the word clusters. Why? Because obviously, like in the 60s, they had clustering in machine learning. It's something that I can trust, I can understand, I can explain, fully transparent, fully scalable, very good for big data. And I can find a million clustering algorithms out there. It's nothing new. I can get a lot of experts on it like this in a summer internship with like a small college or something like that. So what can clustering offer me? Well, you know what? I have a lot of data. I have terabytes and terabytes of data. What if you tell me which of them are relevant to each other? But relevant based on what? On everything. What do you mean everything? Remember, you have a user. Remember, you have a port. Remember, you have a file path. Remember, you have a registry key. Remember, you have an operating system. You have a lot of data. You have a lot of metadata and attributes. As an investigator searcher, I can only do a search for one common characteristic that is identical during a time span. So I can search for as in these logs during 5 minutes of logs. But what if I just said, show me everything that is similar to this alert? Now I'm looking at everything that is similar. So I'm considering user, port, software, timing, everything at the same time. Super duper cheap. And then I look at my alert, and immediately when I click on my alert, I have 60 relevant data points for my consideration, right? And obviously, with the 60 relevant data points for your consideration, you can now have an entire investigation closed up, send it to an LLM that you trust, if you trust LLMs, and they would come back with some sort of recommendations and telling you some sort of scoring, if this is a false positive, if certain investigations are worth doing, if certain queries are worth investigating further, and you can kind of help your SOC become a little more autonomous, if you might say. But this idea of clustering, let's take a look at actually doing it. So I'm an investigator, I feel bad for a breach. Let me look at how can I do clustering. Okay, so in clustering, by the way, I can find clustering in a lot of solutions, like every single solution out there. Like Microsoft Sentinel has clustering, like in notebooks, in AI notebooks, Splunk, machine learning toolkit, data science, deep learning, Cortex from Palo Alto has some sort of a clustering or some sort of a notebook for AI. So clustering is not particularly hard to find. It's always there. You can easily write a clustering algorithm with ChatGPT, and it would actually be pretty good. But back to the point, now that I have this clustering, what are some of the challenges? So when I do this internship that you're talking about, when I do this project, what are some of the challenges that would be highlighted? Well, what are you clustering on? Am I clustering on 5 minutes of data? Or am I clustering on 100 gigabytes of data? Or am I clustering on everything in the world? Or am I clustering in different batches and then adding them up somehow? Because if I cluster on everything that happened so far, what do I do with the data that comes tomorrow? Do I just recluster and delete all of the clusters that I had before? Or do I just do the new stuff and evolve? So that would be a challenge. Another challenge would be in the choice of features. So am I clustering based on all of the features? Indeed, as you said, how can I do that? Can I truly use all of the features? So it will be a little bit of a technical challenge to use all of the features. You might end up, at least in the first version, doing selective features. You now have to go back to your drawing board and think, what are the features that I select for something like this? And then you probably want to also deal with data mapping and feature mapping. You might have as an username, but you also might have as an ID or something like that. So other than that, you would also have feature enrichment. Like an alert coming from CrowdStrike might have a lot more information than a syslog. So ideally, I want to enrich that syslog with a little bit of data. I also want to enrich my CrowdStrike. I want to enrich my other, essentially, data types. What kind of enrichment? Let's think about Mitre ATT&CK Techniques. That's a nice enrichment. Everybody might probably agree with it. And it's popular enough. Sure, let me enrich with Mitre ATT&CK Techniques. Why? Because when I go into clustering, I would like to have abstracted data. Fantastic. Is that it? No. You would also come through data encoding. What is data encoding? It allows you to understand similarity. For instance, I'm 26 years old. You immediately know that 26 is very close to 27, very far from 30, right? Or very far from 10. In ports, you don't know that. In ports, port 80 and port 443, or port 8443, or port 8008, or port 8080, or port whatever, are alternative ports. Who knows that? You know that, because you're an expert. The clustering doesn't know that. Clustering would think that 80 and 81 are similar, right? So you now want to tell it the encodings of what this data means. It would need to know that Windows 11 is kind of similar to, let's say, Windows 10, but not very similar to Windows 7, right? And so on and so forth. And then you'd also have to deal with figuring out which clustering model you want to use and which configurations. So you might start thinking, is it even worth it? That sounds like a lot of work. But then you go back to your notes and you think, you know what? No, it is worth it because it's the only way that would work. At the end of the day, I collect terabytes and terabytes. And I know data is gold, that's why I collect it. But am I using it? Not really. In the last year, as an investigator, I maybe touched 50 kilobytes of data. Why am I collecting petabytes and petabytes of data? For fun? For compliance? Ideally, because I want to use it in an investigation, but I cannot possibly use it with searches. So I know that sock clustering is what I need to do. So I go back and I try to fix these issues. So input data and context size, I will find a way to use temporal clustering to essentially have clusters that evolve. And they can capture all of the data in the world, and I don't have to deal with input data or context size. Fantastic. I will also use something called knowledge-based pre-processing or knowledge graphs to utilize entire data. I don't have to select features anymore. Fantastic. And then for feature mapping, I would also use some sort of a semantic mapping model or a data mapping model that allows me to map in real time dynamically, not based on a schema. This idea of I have to have the schema transition into the schema to ingest and whatnot, let's not do that. Let's just have real-time dynamic semantic mapping, right? In real time, if you give any data, let's say to a model like ChatGPT, it will tell you, what the right mapping is, so on. Obviously, I'm not saying you do this with ChatGPT. It's a lot simpler, but I know ChatGPT is popular, and you probably know how it works. And then for feature enrichment, let's assume that we have some sort of a classification pipeline. It would look at an alert, and it would tell you the most resembling technique for that alert, right? And then for data encodings, let's assume that we have all of the encodings. We would have some sort of model generate all of the encodings based on the knowledge in cybersecurity. So the alternative ports example, it's available on Wikipedia, right? So I go to Wikipedia, TCP ports, download that, give it to some sort of model, and tell it, now you know similar ports. I download the knowledge base for similar Mitre attack techniques. Now you know similar Mitre attack techniques. Now you know similar registry keys. Now you know similar file paths. Now you know similar so on and so forth. So that's the encodings. For the models, why do I have to choose a specific model and configuration? Didn't you say clustering is cheap? Yes, it is cheap. Let me use 5 clustering models. Let me use 10. Let me use 20. Why not? So if you do that, you go back to this idea of, let me action it. OK, let's action it. So I use some sort of an attack technique. And everybody here knows Mitre attack, right? OK, anybody needs a refresher on Mitre attack? Not really, OK. High level, left to right, tactics, techniques are a fantastic Wikipedia page where you would see procedural examples, detection advisories, mitigation advisories. If you know what you are looking at is a specific technique, you have all of the knowledge in the world to handle it. Not only that, but techniques have a taxonomy. They have an ontology that allows you to understand sequentiality. So techniques are categorized by tactics, and they allow you to inherently understand sequentiality. So now you can see things like Mitre ATT&CK Flow, where you can see essentially storylines as we just saw together. So let me do the recipe. My recipe is do a classification model to find Mitre attack techniques, and then let me do some sort of clustering. And ideally, after the clustering for similarity, I have some sort of way that tells me this is sequential kill chain. So I need to bring in some sequentiality. So first one is easy. Let's classify events with the relevant attack techniques. Sure, right now you can go to Hugging Face or ChatGPT or whatever, and tell it, you know what, here's some large unlabeled corpus. We did a little bit more than that. But essentially, here's all of the cybersecurity knowledge in the world that I should be reading, but I just have it bookmarked or in open tabs. And instead, you read it and figure it out. And then when I give you an alert, you tell me the technique. And I can help you with fine-tuning by giving you a small labeled corpus, where I give you a small labeled data of here's an alert, here's a technique, and I help you understand the task. So we do that, and it looks pretty neat. You can put any sentence. You got a technique. Fantastic. Proof of concept is done. Moving on. Now I need to cluster events that are related, and I find events that are causal and sequential. So now I need to find clusters. How do I do clusters? I put the data in some sort of a data type, some sort of a data structure. Let's say I put it in a graph so that I allow it to have relationships, and that could encompass my knowledge, could encompass some cyber knowledge. Like I know this registry key is actually linked to this file path and so on and so forth. And then I do something called embedding, which is essentially let's move these data points into a coordinate system like XYZ So now I know this data is here, this other data is here, and now I can find clusters in this data. Not only that, we talked about sequentiality. So now I have a cluster of 60 data points from logs, events, and alerts that are all part of a tactic 1. I now want to look for things that are part of tactic 2, or tactic 3, or tactic 5, or tactic 7. I want to see that this is not a false positive, or this is not an isolated cluster. Because I can still have 60 relevant data points that are all false positives, right? How do I know they're not false positives? Because I know attacks are not going to stop at tactic 1. They're going to be a lot more. So long story short, we do that. We give it a lot of alerts. We see the magnitude reduction. We see the data reduction. And we see sequential flows that were generated. And we take it back to the data owners. And they tell us, you know what, this is actually better than what the humans found, because you found some things that we didn't even notice when we were investigating, because we never really investigate these data types. And that comes back to the logs and telemetry. They never look at it, right? And it would look something like this. So this is like a UI that would show you assets and essentially the tactics and techniques for stuff that is within a specific campaign or within a specific kill chain that was put together automatically. And you can see the timeline. So again, the idea of timeline, sequentiality, and then I also have my assets and entities and identities to consider. So if you go back to your drawing board, it should look something like this. You should have two models, an enrichment model and a clustering model. And you have tons and tons of disjointed data points, logs, alerts, intelligence, events, all of the good stuff. Terabytes and terabytes on the left, few actionable attack flows on the right. And the idea is you go from something that looks like this is a suricata that I just added, and you would see essentially, like here is the enrichment. So I see here I have a tactic and technique, and then I see here I put it in a cluster. So now this cluster has 60 other relevant data points, and now I see that I have a flow. And this flow puts clusters that putting some sort of an attack story or putting some sort of an attack narrative into a single JSON, and I can improve my productivity, improve my time savings, and reduce time to response because I'm actually now responding. I'm never investigating. So I can change my role from an investigator to a responder. My colleague could still be the triager, but he's triaging or she's triaging already contextualized, already correlated stuff. And they're just saying, oh, this is good, this is not good. And now I'm just remediating. No one is actually investigating, right? Because investigation is already done in the most efficient way. Any extra investigation is because it's actually serious. But yeah, 50% less expertise and focus needed for investigators, because your investigators cannot balance all of the context in the world. But essentially, I'll stop it here for your questions. Thank you very much. I appreciate you. Please connect with me on LinkedIn if you have any further questions, or find me later around here. But thank you so much. I appreciate you. Any questions? You must have a ton. I'm happy to take them as well on the side.